Good morning. This is Subhashri from CSC Department SNSCT. Now we are going to see about how does the neural networks work. So let's understand with an example of how a neural network works. Consider neural network for email classification. I have given example here. Here the input layer takes up features like email content. We can take the inbox, right? So the sender information. What are those things inside the email inbox? We have a content, then sender information, subject. These inputs multiplied by adjusted weights pass through the hidden layers. Hidden layers in the sense they are telling us the neurons. The network here through training learns to recognize patterns indicating whether an email is spam email or not. The output layer with the binary activation function predicts whether the email is 1 or not 0. Spam 1 or not 0. So true means 1, false means 0. As the network iteratively refines its weight, through backpropagation, it becomes adept at distinguishing between spam and legitimate emails. The legitimate in this sense, it is not a fake email. Spam in the sense, it is a fake email. So showcasing the practicality of neural networks in real-world applications like email filtration. So working of a neural network. Neural networks are complex systems that mimic some features of the functioning as that of the human brain. What does the human brain do? All the activities are done by these neural networks. So it is composed of an input layer, one or more hidden layers, and an output layer made up of layers of artificial neurons that are coupled together to give an instruction to a brain. That is a processed unit. Okay, the two stages of the basic process are called back propagation, and the next one is a forward propagation. So what is a back forward propagation? Input layer. Each feature in the output layer is represented by a node on the network which receives the input data. So the input layer has a node. Okay, each node is represented by the network which receives the input data. Weights and connections are nothing but the neural connection indicates how strong the connection is. If the weight is high, then the connection is very strong. If the weight is low, the connection is weak. Through training, these weights are changed. Hidden layers in the sense each hidden layer neuron processes inputs by multiplying them by weights, adding them up and then passing them through an activation function. By doing this, non-linearity is introduced, enabling the network to recognize intricate patterns. So what is an output? The final result is produced by repeating the process until the output layer is reached. What is a backpropagation? Loss calculation. The network's output is evaluated against the real goal values and a loss function is used to compute the difference. For a regression problem, the mean squared error is commonly used as the cost function. So the loss function here is represented by a mean squared error MSE, which is equal to 1 by n summation I is equal to 1 to n yi minus yi bar whole square. So we have to calculate the gradient descent here. So what is the gradient descent? Is then used by the network to reduce the loss. So we have to reduce the loss by means of a gradient descent. So what is meant by to lower the inaccuracy, weights are changed based on the derivative of the loss with respect to each weight. Adjusting the weights. The weights are adjusted at each connection by applying this iterative process or backpropagation backward across the network. Training. During training with different data samples, the entire axis of forward propagation, loss calculation and backpropagation is done iteratively, enabling the network to adapt and learn patterns from the data. So what is an activation function? Model nonlinearity is introduced by activation function like rectifier linear unit, that is ReLU or sigmoid. The decision on whether to fire a neuron is based on the whole weighted input. Here we are referring weighted as high value or low value inputs. Okay, then that is a diagrammatic representation which includes input layer. There are neuron 1, 2, 3, 4 and 5. The hidden layers, there are more layers like the input layer and it is hidden 1 to 1 and 1 to many, many to many like that. So many to 1 in that format. So output layer will be 2, neuron 1 and neuron 2, which gives the network of output as a single unit. So this is a back propagation and feed forward propagation method. So learning of a neural network. With the supervised learning, the neural network is guided by a teacher who has access both to the input and output pairs. By comparing these outputs to the teacher, known desired outputs and error signal is generated. First of all, In order to reduce the errors, the network's parameters are changed iteratively and stopped when performance is at an acceptable level. If a performance of a input layer, that means if we get a desired outcome, then the process will be stopped. Learning with unsupervised learning, in the sense equivalent output variables are absent in unsupervised learning, where it have no labeled data. Okay, its main goal is to comprehend incoming data X underlying structure. To instructor is present to offer advice. There will be no instructor. Modeling data patterns and relationships is the intended outcome instead. Words like regression and classification are related to supervised learning, whereas unsupervised learning is associated with clustering and association too. So, learning with reinforcement learning. Through interaction with the environment and feedback in the form of rewards or penalties or the loss functions, the network gains the knowledge. Finding a policy or strategy that optimizes cumulative rewards over time is the goal for the network. This kind is frequently utilized in gaming and decision making applications. So, thank you. Let's see in the next video.